There's an alternate timeline where a company named MacNOS exists. It's a company quite similar to this company, Make Noise, except they do things a little bit differently. In this alternate timeline at MacNOS, they've developed such modules as the Source of Certainty, which always outputs 1 volt. Also, they produced the infamous 24-bit DSP-powered mult. And that's what I want to talk about today. This 24-bit DSP-powered mult was an incredible development for MacNOS, and so we decided to pull it into our timeline here at Make Noise.
Introducing MultiMod. With MultiMod, from one control signal, we create many. First of the new Universal Synthesizer System modules. The MultiMod is the DSP superpowered NUSS mult, allowing us to derive many control signals from one. MultiMod takes a single control signal and copies it 8 times, but further it modifies those copies by weighted adjustment of phase and speed, so the modulation is related to the source, but not identical at each destination. From one control signal, we create many.
This 24-bit DSP-powered mult was an incredible development for MacNOS, and so we decided to pull it into our timeline here at Make Noise. And we developed something called the MultiMod, which is essentially a 24-bit DSP-powered mult. Except, unlike MacNOS, we pushed it a little further than just copying your signals in super high quality at the output. We allowed you to do some more things with those signals. Things like shifting them in time, aka phase, or changing their speeds. This allows you to do what we've been talking about a lot here at Make Noise, which is to take one control signal, and from that one control signal, you could derive many. It's something that I have set up in this patch. I'm only using 4 outputs from the MultiMod, but you'll hear how my one gesture from the press point results in a sort of cascading effect as it ripples through the rest of the patch.
As Tony pointed out, MultiMod has only 3 primary parameters. However, their effect is weighted differently across the 8 outputs, in order to create complex juxtapositions of related control signals from just one input. The 3 parameters are highly interrelated, but we'll attempt to go through one at a time. The time parameter sets the pace for everything else that happens in the module, determining how far into the past the MultiMod will continue to recreate the input. The farther up we turn time, the longer the period of time that is represented at the outputs. This also sets the available modulation depth for the phase and spread parameters. The phase control allows us to add a manually weighted phase offset to each channel so that they repeat copies of the input in succession but still all at the same speed. For example, if we send a CV event like this manual pressure out from press point, we can hear that the signal is copied at each output at the speed that it is input. With phase turned all the way down, the channels are operating in tandem. If we turn it up, we encounter an increasing delay across the channels as the outputs go increasingly out of phase with each other, maxing out the knob value with channels 1 and 8 being a full 180 degrees out of phase. Time sets the total modulation depth for this parameter. In fact, the phase parameter and also the spread and time parameters can be pushed well beyond their panel control limits by adding additional CV to their inputs. We'll go into detail on that in a future video. Right now, spread is at 12 o'clock, and therefore the outputs all operate at the same speed as the time setting, and it is easy to hear the length of time represented as phase shifts across the 8 outputs. If we begin to turn spread up, the top row of channel outputs begin to speed up relative to the time parameter, while the bottom row slows down. This means that outputs on the top row may play the same event multiple times, since they are reading more quickly through the same length of elapsed time as the bottom channels read more slowly, and may play through any given event less than once. If we turn spread down from 12 o'clock, the two rows of channels behave in opposite manner, with the top row slowing down and the bottom row speeding up. Channels 1 and 8 are always the channels affected the most by spread, while the inner channels 4 and 5 are affected the least. Now the channels are operating at 8 different speeds and thus constantly drifting in and out of phase with each other. If we return to 12 o'clock on spread, we will see that they are not operating in tandem even with phase turned down. This behavior allows for interesting phase music patches by creating any number of phase relations among channels. But we can also force the channels back to the current time and phase position anytime we like by pressing reset or sending a gate to the reset input.
Modular synthesis has grown to a point where we have everything we could possibly need to make the music we know how to make. And so here at Make Noise, we've started trying to come up with modules that allow us to make music that we don't know how to make yet. And the MultiMod is the first of those modules. Now, here in the back rooms of Make Noise, we've been referring to these new modules as the new universal synthesizer modules. I have no idea how far we're going to get into these, and I'd love to tell you about all the other ones that we're developing right now, but the problem is that some of them, or maybe even most of them, will never see the light of day. They're untested concepts. We're going to take the time to build them, test them, see how functional they are, see if they actually do allow us to make music we don't know how to make yet, to find new unfound sounds, essentially. And if they do, then obviously we'll tell you all about them and we'll build them as well. But if they don't, they'll just get relegated to the shelves alongside other such developments as the Control Cell series, which we sold at NAMM for 3 years, but never produced.
I can control the Control Cell modules both globally using this Control Cell G.
We are showing the Control Cell C and the Control Cell V. They're both part of the same series. They talk to each other and communicate with each other.
But let me back up a little bit, because making the MultiMod wasn't as easy as just taking this concept, this idea that I had, and producing it. So when we first started talking about the new universal synthesizer system, the thing that I immediately recognized was that there was no way we were going to be able to build any of these ideas when I was the only person in the engineering department here at Make Noise. We were going to need some really smart folks to join me in Make Noise engineering to help us build these. And so myself and Ryan, our general manager, spent several months reviewing resumes and interviewing folks. And we landed on a couple of really bright, smart, energetic individuals, Mark and Ben, who now, together with myself, are gonna design these modules. The rest of the folks here at Make Noise are gonna help us fine-tune them into something that you would actually want to play.
Aside from time, spread, and phase, the other important settings on the MultiMod are the hold button and the Reid shape. Reid shape is controlled by the shape button and indicated by the shape activity window. The default shape displays as red and is forward Reid. Everything we've done so far is using this shape. It plays back the copies of the signals in the forward direction just as they came in. To demonstrate this, let's also use hold. When we press hold, MultiMod will begin to ignore the input. Instead, every signal that has been represented in the last time cycle will be looped indefinitely. Here's an accelerating series of percussive functions from maths. As you can hear, each output represents this shape as when we entered it, of course sped up or slowed down by the various controls, but repeating in the same direction. Let's switch to the next shape. Green, backward Reid. Now we can hear that this same inscribed set of functions is output, but now backward. Next up we have blue, ping pong Reid. This plays the functions forward, then backward. Next up, purple, wow and flutter ping pong. Like ping pong, this plays forward, then backward, but slows down as it reaches the end or beginning. Next we have pink, which is stair step, jumping from one moment to another at the internal rate set by spread. Orange is random access Reid, which also jumps from one moment to another, but not in order, instead selecting moments randomly. Finally, yellow is ramplets, in which the channel also jumps from one moment to another randomly, but then continues forward at the rate set by spread until the next random jump.
So once we had this new engineering team assembled, first thing we had to do was develop some new hardware, which is crazy because we just spent a whole lot of time and money developing the Spectrophone hardware, but we needed something different for these modules because they're largely control signal based. We needed a lot of I/O and we needed a lot of illumination to tell people what that I/O was doing. We had to go back and design a whole new hardware. And I'm really excited about the hardware we developed because it's unlike any hardware we've done before. The amount of inputs and the amount of outputs is unlike any other DSP that I know on the market, DSP module. One of the primary goals with this new hardware was to make some digital modules that could be used like analog modules. And by that, what I'm talking about is that thing that happens oftentimes with analog modules where they don't read in negative voltages, or maybe they have a very limited control voltage range. For example, maybe they only respond up to 5 volts, 0 to 5 volts even sometimes. So we wanted to avoid that, and we wanted to create a DSP hardware that approached the I/O specifications of an analog hardware. And the MultiMod being the first, it has I/O ranges of 20 volts, plus and minus 10 volts on the inputs and outputs, that is. The outputs are all 24-bit, which gives us really good resolution for creating our control signals. And several of the inputs are also 24-bit. So once we had this new hardware developed, the concept went through many, many variants. And the reason being that there wasn't really a lot of parallels We weren't just making another version of a VCO or filter, so we really had no idea how big or small it needed to be. And we had no idea how many parameters we really needed to make it work effectively. So we went through many different iterations of the UI and the parameter set. And we settled on something that's quite slim at just 10 HP, but with 8 outputs. It's 10 outputs and 10 HP. It's really packs a lot of power into a small amount of space. And the reason we went with something smaller is because we kind of imagined this as being the super powered mult for our new synthesizer system, the new universal synthesizer system. So by making it a little smaller, we imagined somebody could have maybe more than one of these, or at least that by having one of these, it wouldn't necessarily limit them from having some of the other modules, which will probably have to be a little larger.
You may have noticed that some of the Reid shapes are analogous to standard LFO waveform shapes. Forward Reid is like a ramp wave. Backward Reid is like a sawtooth wave. Ping pong is like a triangle. Wow and flutter is like a sine. In fact, when the MultiMod signal input is not in use, the selected Reid shape will be used to generate an LFO, which it will then copy 8 times at the outputs. Let's take a look at the LFO shapes. Red is ramp. Green is sawtooth. Blue is triangle. Purple is sine. Pink is square, since staircase does not have much meaning when internally generated. Orange is stepped random. Yellow is smooth random.
Let me get back to that core concept of from one control signal, we create many. I think that is truly the future of modular synthesis. Being able to, with just a single parameter or maybe a handful of parameters, in this case with MultiMod, you have 3 parameters. But with those 3 parameters, you can create dramatic sweeping changes through a patch. Now, I'm not saying we're trying to make patching a modular synthesizer easier. In fact, I think we're doing quite the opposite with MultiMod. I think it's gonna make patching your synthesizer harder, at least initially, and then you'll reach a point where, again, you might not be able to create some of those patches that you were getting without using the MultiMod. And I feel confident in saying that.
Because I've experienced it myself.
There are many possible uses for the Reid shapes and the internally generated LFO shapes. A few examples. The ramp shape can generate several copies of a sequence at different speeds. Or the staircase shape can be used to extract subsequences and supersequences from a single sequencer channel. Square LFOs can be used as a series of continually evolving overlapped gate streams. Create new phase relationships over time with the spread parameter. Then return it to 12 to lock in the current relationship. Which can then be phase shifted in and out manually. Or return to original phase by resetting.
We don't totally know what we're doing here because we don't know what we're doing, and that is true. We're building things that we don't necessarily have a blueprint for. The reason we're doing that is it's not easy, and it could potentially cost us a lot of time and money without having a lot of results. But I honestly feel like the essential core of our system, but also most modular systems, is well established by the existing offerings from the existing companies. And it's time now for us to start looking into the future and trying to come up with something that can spark and innovate new musical ideas. And in some ways, I feel like for me personally, and probably for other folks around the shop, especially folks like Walker, we're chasing that feeling that we had when we first got into modular synthesis. And we didn't know very well how even the basic core concepts functioned. And there was a certain beauty to that. There was it was an incredible feeling to sit down in front of this instrument and have no idea how the individual components worked, and to just see this journey ahead of you and to set off on that journey was a great feeling.
We have not yet discovered all the ways, or even most of the ways, to use MultiMod. Yet. To help kickstart that journey, we've also sent MultiMods to our friends Sarah Belle Reid and Jeremy, aka Red Means Recording. Sarah and Jeremy are both talented and creative musicians who are going to take different approaches from those of us here at Make Noise, and different approaches from each other too. So head over to their channels, where videos on MultiMod will also be coming out today. In the coming weeks, we'll post plenty more patch ideas as we discover them, And we also have some video in the works from our old friend James Sigler. And don't forget to stay tuned to what Peter's up to over on the Make Noise Instagram. MultiMod has already started shipping to dealers worldwide and is available to order now. Check your favorite store for ordering info. Thanks for watching, and happy patching.